Hi guys, how are you? How are you? Thank you. So I want us now to look at the formulas that we shall be using in this particular subtopic. So I hope everybody is okay. Yesterday we looked at the options, and we said that we have two types of options. That is a call option. Then we have put option. Call option and put options. So the formula or models that are used to calculate the value of option was given by somebody called Black-Scholes. So Black-Scholes model is what is used to value the value of call option, or basically the value of options. So we have put option, and then we also have call options. Now the formulas that we will be using, they are quite complicated, but you have to understand them. The good thing is that in exam, they normally give the formulas. They'll give you the formulas. So I want to just write them down. So for call option, value of call option is normally rated like that, BC. That means that value of call option is normally given as P ND1 minus E ND2 all over E RT. That is how it's normally written. So you need to, the most important thing here is now how to get the P. This one is N, ND1. The most important thing is how to get the first one, D1. So D1 is normally given as, that is this one here, and then we have D2. So D1 is normally given as Ln into P all over E plus R plus the variance over 2. Then all these, you have it over standard deviation of time. That is a P1. I'm saying that the good thing with this is that most of the time, the examiner normally give you the formula in the question. They will tell you the formula. So that is the formula. This Ln basically means natural logarithm. So that is D1. Then D2 is equal to, D2 is D1 minus this one here. So D2, Florence, I've written here that is the call option. And the call option is also called VC. That is the value of call. So it is the value of call option. And this is the formula. That is how it looks like. So you need to get the value of D1 and D2. So you'll have to calculate them separately before you join there. So that is the formula for getting D1 or ND1. You would call it, it can be D1 or ND1, still the same. D1 or ND1, the same. The only thing that you now look for is this one separate and this one. ND1 and ND2 are these ones. So that means that the most important thing here is to understand how to calculate this. Once we have E, this one is now easier to calculate. Now, once you've gotten the value of call option, we can now proceed and get the value of put option. Value of put option. So put option normally written like valuation or value of put option is normally VP. So VC is the value of call, but VP is the value of put. So it is normally the same as the VC, that is the value of call, minus P. P, you know, this one, the P that we have there, minus P plus P all over ERT minus P all over ERT. Or you can call it E minus E all over ERT, so that we can separate them. Now, from what we did yesterday, so this one is RT. It is E RT. You'll notice that we have the bigger E, and then there is also small e. This small e, this one, it is normally called Euler's constant. It's normally called Euler's constant. It's normally called Euler's constant. It is normally calculated. It's normally calculated, and it is a constant figure. So we shall be able to go through that. Now, from the example that we did yesterday, you remember we were having P somewhere, we also have E. What does E represent? What does E represent? From what you are having yesterday, what does E represent? Exercise price, that is what you say. And then P, E was exercise price, and then P. P is the price. And then R, you can see now you are getting them here. So we have P, we have E. R was the risk-free rate of return. And then we have this one, variance over 2. Then we have T here. And I say that if you're given this one, they have given you variance, that means that it is already standard deviation squared. So if you want the standard deviation alone, then you have to get the square root of that variance. The square root of variance. The square root of variance. Now, I think up to there, we are okay. Maybe we just need to do an example now so that we can see how this goes. Most of the question papers they share, I want to share with you this one. They normally give you most question papers, they do give. You see, like here, they're giving you the formula. So the examiner will tell you. Now, instead of P, they call it S, ND1. Instead of E, they call it K. So that is how it looks like. Now, you can see this one is K, then E, R, T, ND2. So you see now, this one here, this one that we are having here, you can make it like what they are given there. So what you simply do, we have E, ND2 over ERT. If you want to make this one, to remove it from the denominator, you put it raised to power negative, so that you have E times, so it will be E and then ER raised to RT, then times ND2. Remember, we're going to calculate the ND2 separate. So ND2 will have a figure. So basically, we are having E times ND2. So this one is the same as E times Euler's constant, where if you remove it from the denominator first, so it is on numerator, it becomes negative RT. So it is like E times this times this. So it is E times this times this. This one is a figure. So it is not part of this. It is the exercise price times the value of ND2. So some books might give you like this. Some books might just have it like this. It means the same thing. It is only that they are now taken it from here. They are marked like this. So it is called E raised to negative RT. But if you want to leave it under there, then it becomes just like that. So whatever is easier for you, that is what you shall use. That is what you shall be able to use. Okay. Number 2. The one that we are having here, the P, sometimes they can call it S, right? And then they call that E, they call it K. That does not change anything. Doesn't change anything at all. You'll be able to remember. So let's look at what they were giving you. So we have S, which is the P, and they say P was the price, and I say that price is the same as the present value. And they're telling you that S, which represents P, is the current value of the underlying asset. Current and present is the same thing. Then we have exercise price. It is called exercise or striking. Wakati unacheza mpira, you are exercising. You are also striking. So it is called striking price or exercise price. Then they mean the same thing. Current price or net present value or present price or present value, basically it means the same thing. That is what is available in the market. So this is the current value of the asset currently in the market, and this is what you want to exercise. Then T is the life to expiry of the option, which is the same as the period or time in terms of years. Then we have risk-free, the same as riskless, risk-free or riskless. Then we have standard deviation, which I say it is a risk. So these are almost the same. Which year was this? So this is which year? That was 2022 April. Another one, another year that they brought the same was in just 1 minute. So we're going to look at an example of December 2014. Question number 5. I know you don't have it. The one that we have start from 2015. You write this question very fast. Do you know the differences between a European option and American option? Mary, what are the differences? What is the difference? Yeah. What is the difference between American option and European option? Mary? Just unmute yourself and talk. I need Mary Jane, or Edwin. We don't know the differences between American option and Edwin. Kindly assist me there. The difference between American option and European option. Okay, anybody? Anybody who can try? Anybody who can try?
Under European option, you only exercise upon maturity. Under American option, you can exercise anytime before maturity.
Yes. An examiner can ask that question. So when I asked, na unanyamaza, I really don't know. Okay, so I want to try that a European option, a European call option, a European call option, trading at the securities exchange. A European call option, trading at the securities exchange, has an exercise price of shillings 40. A European call option trading at securities exchange has got an exercise price of E of 40. Exercise price of 40 has an exercise price of 40. Its maturity date is 6 months from now. The maturity date is 6 months from now. Its maturity date is 6 months from now. Its maturity date is 6 months from now. Its maturity date is 6 months from now. The current stock price is shillings 28. The current stock price is shillings 28. That is the price. 28. So you need to know, don't confuse the two. If they say the current price, that is a P, that is a net present value, the present value, it is P, the current price, this one. So don't confuse these two. We have the excess price and then the current price is given like that. So the current price, the current stock price is 28 shillings. So I'm saying, I'll repeat, I'm saying that a European option, European call option, trading at the securities exchange has an exercise price of 40 shillings, an exercise price of 40 shillings. An exercise price of 40 shillings. Its maturity date is 6 months from now. Its maturity date is 6 months from now. The current stock price is shillings 28. The current stock price is shillings 28. And the instantaneous And the instantaneous variance of the return of the underlying asset is 0.5. So instantaneous variance. So you're given variance. So variance, you know how it is written. It is this one, not this. This one is not variance. This is variance. So instantaneous variance is 0.5. Yeah. So instantaneous variance of the return of the underlying asset. Instantaneous variance of the return of the underlying asset is 0.5. The risk-free rate is 6%. The risk-free rate is 6%. The risk-free rate is 6%. The risk-free rate is 6% required. 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 Use the Black-Scholes option pricing model. Use the Black-Scholes option pricing model. Use the Black-Scholes option pricing model required. Use the Black-Scholes option. It is a model for pricing options. It is called option pricing model. Model is just a formula. Model is just a formula. So use the Black-Scholes like that. Use the Black-Scholes option pricing model to compute the value of the call option. To compute the value of the call option. Compute the value of call option. Compute the value of call option. Use the Black-Scholes option pricing model to compute the value of call option. So we know the formula for calculating the call option has got both D1 and D2, right? So you need to be able to calculate them separately so that you can be able to arrive at the answer. This one, they were given the formula hint. They will tell you use or hint. In the question, they tell you hint. Like in this case, they were saying that hint. Then in siri ni kwamba C, which is the call option, is equal to S ND1, S ND1 minus E ND2 ND2. Then they have also given ND1. Most of the time they give D1 is equal to ln, that is a natural logarithm, ln of S, now not B. They now call it S all over E. They can even call this A, but here they've decided to maintain E. Plus R plus the variance all over 2. Then they have T there. All this into T. That is what they gave. Then they have given us D2 as well. D2 is very easy. It is normally D1 that you have calculated here minus this one. This one minus that. So that is what they have given you as hint. It means that now it's your role to just punch in. Okay. Where will you start from? Where will you start from? You need to start by calculating D1. But then you'll now have S, which is now this one here, because now they ordered it like that. So basic kata is now P or S. Now replace it here, and then you have it over 40. Then you proceed. So let's do it together. One thing that you need to remember, two things that you need to remember is that this one, when you want to convert it to standard deviation, you have to get the square root of that. So D is equal to the square root of D1, T1, or yes. So you need to get the square root of that. Number two, always remember to change the time into years. Even if they give you 3 months, make it into years. Don't use it 6 ikiwa hivyo, utakuwa umepata wrong from the start. Make the time to be in years. Also, ensure that you understand what you're given. If the examiner gave you standard deviation, then you know that whenever you want to now have variance, you simply square it. But here, use the standard deviation that you're given. If the examiner has given you the variance, know that you need to get the square root so that you can use it here as standard deviation. So you need to again listen carefully to know what have you been given. Is it variance or standard deviation? Are we together? Okay. So we can start solving this by looking at some of these items. Let's look at T. So we have T is equal to 0.5, right? Or basically 6 months all over 12. So that is 0.5 years. Then we have Euler's constant, which is written like that, right? That is how the formula looks like, right? Euler's constant raised to negative RT. So this one is the same as negative R and T. What are they? R is 6%. T is 0.5. 6% is the same as 0.03. This one. Still, 6% is the same. No, 0.06, sorry. 6% is the same as this times time, which we now know. So time is 0.5. When you multiply this, what you get? You tuandike hapa. Maana vile nimefanya. Have R rate, which is 6%. Then we have time. If it is 1 year, just put 1. So multiply. What are you getting? Just type me there. Open a calculator. Me sina calculator. Me sina calculator. Me sina calculator. Sijui Moses amepeleka wapi leo. I had it yesterday. I was very happy. Today sijui mwalimu mwingine amechukua. That is what you're getting. So we are having 0.03. 0.03. In your calculator, there is something that looks like this. Are you able to see it in your calculator? Topista, kwani umelog in how? I'm seeing Topista left, and then Topista is replying. Did you leave before? Did you join? Then you left before joining, or you umelog in twice? Now, if you can see this, something that looks like this, hebu finya hiyo, finya, alafu weke negative 0 point. Finya hiyo, alafu weke negative 0.03. What do you get? Kama unaona hii kitu kwa calculator. Finya, alafu weke hiyo. What are you getting? Oh, shift, sawa. So you do shift so that you can activate it. That means that in that button there are two of them. So zikiwa mbili, then you need to finya shift first so that you activate it. Thank you so much, Ruth. Aya, endelea sasa. Means that kwa hiyo button ziko mbili. Finya shift kwanza. Topista hivyo finya shift first, then weke hii. Is there anybody who has tried it? Ruth is getting 0.97. Topista is saying that yeye anapata 1.03 something. So Ruth, I want you to explain to them what you've done. Edwin, one of you to explain. What have you done? Just talk. It's about learning. Ndio waweze kutumia hiyo. Hii inaweza kuja kwa mtihani. Let me check if it came last time. Kama hii kuja itakuja saa hii. Upende usipende. Omba Mungu ikuje. I don't know kama ilikuwa last time. Let me see. Last sitting December. I'm praying that it did come ndio ikuje so that upite haraka. Unajua ikikuja unapita asubuhi. Ilikuwa I don't know. Maybe now that ilikuja money market itakuja kwa nguvu. Hiyo na money market they normally balance them. Hapa sioni dalili ya money market. Examiners, that is what they do. This is what they do. That question and money market, they normally balance them. So ukiangalia hii ni kama money market hawakuleta. Now if they don't bring money market, this time money market lazima ikuje. Another thing, unaona hapa they did bring for you that formula for calculating the formula models for predicting corporate failure. Uliona hiyo? Hiyo hawakuleta last time. Which formula is it? Which model is it? There are 2 of them for predicting corporate failure. The first one is Altman's Z-score. And the other one that I taught you is called, there are 2.
Springate.
Sasa hizo mbili last sitting hawakuleta. Most likely this time wataleta. Now last sitting walileta hii. They normally exchange it with the other one, money market. So most likely money market itakuja. So as much as you're learning this one, they can bring it. If people didn't pass, you know what they normally do? If they realize that people didn't pass this, wanairudia. But if they realize that watu waliopita hivi vizuri, they now bring money market. So I'm trying to think that Altman's model and money market will come. The one that we did yesterday. I'm just thinking like that. And they normally come in question number 4 or 5. So we angalia question number 4 and 5. Kianza, uone kama iko rahisi. Otherwise, wakifanya mchezo walete hii, toroka nayo kwa sababu this one, the formula is very clear. Haitakusumbua hata. So be prepared. So the answer there that we are getting is that this one is giving you 0.97. Is it 97 only? You know, you need to be more accurate. And for you to be accurate, you need to have it in 4 decimal places. So, Krista, you are saying that which mistake did you do? Mbona ulipata ile?
Sikutumia the negative sign.
Oh, sawa. So what you did, shift hii negative this na unapata hiyo. So hapo tumefaulu. Haya. So tushapata hiyo figure. Keep it safe and then we also have this. Now we can get D1. One, you can now get, we say that D1 is equal to natural logarithm of S all over E, right? Plus into R plus square root of that all over 2 T, right? In this one we have so I hope that is okay. So let's come here and have our ln into, this one is given as 28.0. So we have 28 over 40 into plus rate we're given as 0.6, 0.06% still. Plus, here we are given variance already, so you don't need to change it again. It is already variance. So have it like that. You don't square it again. If this was standard deviation, then now you square it. But because it is variance, it is already squared. Over 2 into time. Time, we say that is 0.5. 0.5. Is that the correct? What will the answer now? EQ2. Because I wanted to get the value. You can do it later. Anyway, it is up to you. I wanted to know what the figure, what that means in terms of figures, so that when I'll be doing that, I simply insert. So tuko hapo, which figure are you getting? When you are here, just divide this and this, sort the bracket first. Divide this with this, then add it here. See, it is 0.25 plus this. Then multiply with this. So give me the answer. So hapa utakuwa na ln of, this seems like 0, so it is 0.7, right? Plus, hii inakaa kama 25, so it will be 0.31 times 0.5. I don't know. Just try and tell me what are you doing. Is this okay? Nataka tusonge pamoja. Hii na hii ziko hivyo. And whatever Mr. Norbert taught you today, take it seriously. I'm not sure why he decided to come and do that class. Make sure that you take them seriously. So get me the answer there. What are you getting? I just need this one. Confirm to me that this is okay. Hivi na hii pia. Then in your table, on your what? The calculator. Finya tu hii ln 0.7. ln 0.7. Let's do them separately. ln 0.7, what are you getting? Then this one. Get for me ln on your calc. Finya ln. I don't know whether you need to finya shift again, but check. I don't have the calculator. On this column, hii column ya right, mwisho huku, I'm sure kuna kitu inataka kama ln toward the top. Finya hiyo na hii. What are you getting? Which figure? It will be ln 0.7 plus now what you're getting here. Natural logarithm of 0.7 is natural log. Can somebody speak to me? Because we are not moving. We are not moving. Can somebody speak to me and tell me what you're getting? Let's start with this. Now, of course, this one ni ya juu. So once umeipata hii, you'll have it over. You'll have this one over. This one is 0 point. Square root ya 0.5 ni 0.5. Square root of this times the square root of time, which is also 0.5. These two should give you 0.5. So answer ya chini is 0.5. Same kweli. Jaribu. Square root of this times square root of this is the same as this. So hapo tumemalizana naye. Calculate for me this. What are you getting? Okay. You guys are not helping me. You guys are not helping me. Calculator, shike hivi. Alafu finye 28 divided by 40. Unapata hiyo, number 1. Number 2, 0.5 divided by 2. You get some answers there. Then you add plus 0.06. Get that. Then times 0.5. Surely. Kwani hii ni kitu ngumu? Hiyo ni kitu ngumu? You are here. Now tell me. Logarithm ln of 0.7 ni nini? Somebody to speak. I have not muted you guys. Finya calculator alafu niambie what are you seeing? Ongea. Negative. So this one you're getting negative. Okay, so you're getting negative 3, negative 0.3, 5, 6, 7. When you add this, what are you getting? So it is negative 0.3, 5, 6, 7 plus 0.155. So here we're going to have negative 0.2017 all over 0.5. What do you get? That answer divided by 0.5. Negative 0.4034. Nilikuwa nataka upike hapa. Na mtaki kuongea hapa. Now, you now need to convert this one to normal, or we call it normalize. Do what? Normalize. How do you normalize? How do you normalize? So the answer that you're getting here is now the D1. D1. We are now telling you proceed or semi-normalize. That is D1. Normalize. So if you're normalizing, you have, if it is negative, you say 5 minus, no, 0.5 minus the answer that you're getting, minus 0.4034. If it was positive, you say 0.5 plus 0.4034. Hii figure, kama ingekuwa positive, you add 0.05. But hata sahi ni kama ume add 2. Only that if you add it is already negative. So if you have this minus, this plus minus, so the answer, the effect is minus. And when you have plus and minus, the effect is minus. So when you normalize, what do you get? What do you get when you normalize?
Hiyo 0.5 deno unatoa wapi?
Normalize first. What do you get? Nipe tu figure hiyo nitakujibu. Nipe figure kwanza. You get 0 point, is this 0.9 or 0 point? Let me see. Are you getting 0.9 or 0.09? So let me answer you now. I can see Florence doesn't want to move on. Kama hajaambiwa. Florence, what we are trying to say, this is D1. That is D1 only. This one is D1. But then we have N D1. This one is D1. This one is ND1. So what we've gotten here is D1, not ND1. When you want to make it ND1, you normalize. Meaning N here is means that you are getting it from the normal distribution table. So it means that the D1, you need to get it from the normal distribution table. That is where the N comes from. On normal distribution table, the table looks like this. That is how the normal, the graph. So normally, this one is 0.5, is a half. The fact that it is negative means that it is falling on this side of half. So this is negative side, this one is positive side. So the region that we're talking about is the region that is included. If it is positive, you start counting from here, going like this. So this one will be 0.5, 0.6, 0.7, up to 1. Pure fold. Upper is 0. So when you are moving from this side, going forward, you start adding. However, if it is positive, it means that from the time we were here, you move positive 4 ahead. So it means that ukianza hapa mpaka positive 0.4 umefika mahali hapa. So it is 0.9. If it was 5, 0.5 plus 4 plus 0.4, 0.9. You are almost half. You are almost full. Almost full. You are adding towards full. Lakini kama umepata negative, it means that you are moving backwards, almost 0. So you are moving from this side. So that is why we less. So probably here is 4. Here is maybe 3. So that is why we consider this side to be negative, this side to be positive. So they are ranging from here. Are you moving toward the positive side of 0.5 or towards the negative side of 0.5? So on this graph, the normal distribution graph there, this one is in the middle. Then now the side will tell us where you are. You are on this side or on the other side. So that is why when you have it now 0.5 minus 0.1 or like 0.4, the way you're saying, unapata 9, 0.9, It means that 0.909, it can't be 9, 0.09. It means that you are towards this end, right? But we shall look at that first. I don't want to confuse you. First, let's move to first. There is another step that I want us to go through before we come there. We shall normalize it, but we shall come there. So from here, let me pick from where I left. We have D1. That is not ND1, that is D1. The formula is D1, not ND1. You have not normalized it up to here. So from here, we can get D2. Before you come to ND2, you can come to D2. So D2 is D1 minus. Can somebody get me that one? What does it mean? What is the answer? What is the answer there? For D2, before you normalize, I was almost passing that stage, but get me that first. Before we normalize, what are you getting there? Negative. That is a D1. Just have for me this figure. D1 is now this one 0.4034 minus what we are having here, which is 0.5. So we are going to have negative 0.9034. So that is what we have as D2. I want you to ignore what I was trying to normalize first. Get for me D2 and D1. Are we all there? Tumefika hapo kila mtu? Umeona vile tumeflow hadi hapa? We got our D1 and then D2. Are we all there? Are we all there? Edwin is there. Jen, Leah, Henry. Today sijaona Milka. What happened? Milka aligive up. Alisikia mtihani watu wamebuka hadi akagive up. So everybody is there. Fine. Now, after umefika hapo, umepata D1, I want you now to go to the table, normal table, before you go to that graph. That graph that I gave was only for illustration why we add or subtract. So you go to the normal table. Wakati examiner amekupea hii, they will normally give you normal table, distribution table. This is the table. Unaona vile ina flow. So that is why we were saying hapa ni positive 0.4 something hadi hapa. Huku ni negative. Huku ni positive. So unamu ukienda hivyo. Sasa, but anyway, don't worry about this. The table will be given the way you are given this one. Normal distribution table, normal curve. So the figure that you're seeing here, round it off to 2 decimal places so that we have negative 0.90. That is a D, D1, D2. D1 is negative 0.40 because of rounding off. So I want now to move and look for these figures. Ignore the negative side first when you are checking on the table. Ignore the negative side. Ignore the negative side. If you ignore the negative sign, you'll find a figure that looks like this. negative sign. So we have 0.4. Then what is after 0.4? This one. 0, 0. This one. But if you have it to 6, to the other one was how many decimal places? It is 0.4, then 0, 0, 1, 0, 2, 0, 3. If you have it to 0, 3, utafika hapa. Naona? If you have a 0.4, 0, 3, utafika hapa. If you have it 0.4, 0, 0, utakuwa hapa. Somebody upon a question. Sioni anything. Haoni anything. Is there anybody who is seeing anything? Taka tuende pole pole. Is there anybody who is seeing anything? You mean hakuna mwenye ameona anything? Sioni anything. Aya. I'm saying, come to the table. Let me just give example with this one. So it starts with 0, ignore the negative sign. Start 0, 9. 0, 9. Let us zoom. So you come here, 0, 9. We have this one, 0.9. 0.9 up to here, 0.9. So then now you move along like that. So that one we have 0.90. After 9, number gani iko hapo? You picked 0.9. The next number that is here is 0. So we have 0.00. Hii ushatoa 9. So hii imebaki 0, 0, hii ni 0. Kama ni 1, inakuwa 0.01 because hii 9 ushatoa na hii pia umetoa. So umebaki na 0.01. But hapa tuko na 0.00. Kama tunaelewana. The same with 4. You are having 0.4. 0, 3, 4. So come and pick 0.4. Umebaki na nini kwa hiyo figure? What you are remaining, ukitoa 0.4, umebaki na 0.0. Sasa hii ni 0, 0, 3, 4. But the options that we are having on this side, the columns, the options that we're having on the columns, there is no 3 decimal places. We only have 1 and 2. In and E. Right? We only have these 2 up to here. Sasa, kama ingekuwa 3, then you could have moved up to 3. But there are only 2. In and E. That is why I'm saying, for these cases, you can truncate it up to here. You want to truncate up to here. Because the columns don't provide for this decimal place. We only have 1, 2. I want you to see how that 1, 2 comes. We were having 0.4, so we put it for 0.4. Then, as we proceed now, we have 0, 0, which is this one. We don't have 3 decimal places. It's only 1, 2. Upper 1, 2, 1, 2. So the next figure, ukitoa hiyo 4 ni 0, which is this one. Hii. Kama ingekuwa 1 ungekuja hapa. Kama ingekuwa 3 ungekuja hapa. 4 ungekuja hapa. 5 like that order. After 4, the next figure ni sio 1. Kama ni 1, you look for where 1 is. So kama ni 1 hapa, you look for where is written 0.01 columns. If it was 3 here, you look for 0.03. Because hapa ni 0.4 ushamoa, you umemoa. Umeangalia across. Let me now repeat. So you are coming here to look for it across. So we have this 0.00 under 4. It was 4,040. So hapa. So that is the figure that you pick. We are now saying that you normalize now. So we are going to have that figure, which is negative. So being that is negative, ushaona hiyo figure ni 0.1554. 0.1554. So being that it was on the negative side, you're going to have 0.5, which now we know, minus, or it should be plus negative. So it is the same as minus. So minus 0.1554. That is for D1. D1 tunaangalia 4, D2 tunaangalia 9 sasa. So for 9, you come to 9, scroll up to 9 where 9 is. Unakuja hapa, tafuta 9 hapa kwa hii Z number. 9 ni hii. You come across, unapata hii figure. Right? Then now you read, because it is only up to 0. 0 ilikuwa hapa. Hii ni 0, alafu 9, alafu 0. So hii ni 0. You come here. So what are you getting? 3159. 3159. One-tailed. Just 1 minute. I'm seeing this one is written one-tailed. Areas under the one-tailed standard. Let me see if we have another table that is two-tailed. Najua tables pia ni tofauti. Normal distribution table. Ni annuity. But in exam, they will only give you one table, so you'll not have a problem in choosing the table that they have given you. That is annuity. Let me check 2016. I'm sure kuna table walipeana hapo. But I'm hoping that now you know how to read the table. Standard, normal, cumulative. So here wajasema kama ni one-tailed. In a cumulative distribution table. Normal, cumulative. And let me see, this is 2018. Hizo tables ni tofauti. Ile wameandika one-tailed, this one cumulative distribution table. I just need the normal table. Normal table. Ini hapo as annuity 2016 should be there. Normal distribution table ini areas under standard normal curve. Normal curve. Normal curve is the same 0.155. Alafu ingine ini we setting 20 November. November. So that is the setting is 2016. So probably this is the one that was used here. So now if formula was here, so they were given a table. So the table is this one here. This one. Kwa hivyo wanatumia hii. So you pick this figure. 0, hii ni 4, 0.40, 0.41. 0.43. So kama hapa ingekuwa 0.41, unachukua hiyo 0.41. 0.43 next 0.43. So the table they will give you, the table that they have given you, hiyo ndio unatumia. So if your figure was negative, just pick whatever you're getting, but now you take 0.5 minus that. If it was positive, just pick whatever they have given you, then have 0.5 plus whatever you're getting. So sisi tumepata 0 point. That is what we're getting on the normal distribution table. So you add this, meaning that you are, now we are saying that you are normalizing it. you are getting the figure from the normal distribution table. So that will be your ND1. So ND1, you are now normalizing normalizing 1. So you have to get this, and that will give you 0.6554. And then normalize this D2. D2 was this. So we can check it from the table. Just make sure that you have the table. You come to the table that they have given you, 0.9, this one, 3159, 3159. So you add it there. So you have 0.5 minus, because it's also negative, 0.3159. So that will give you, oh, this one, if you minus, you get, actually added, you get, if you minus, what do you get? What do you get if you minus? 0.5 minus 0.1554. So the answer here should have been 0.446. Then this one, if you minus 3159, you're getting 0.1841. Now you normalize them. So this is now what we call ND1 that we use here. Where is that formula where we are having ND1? I think we found it somewhere when you're looking at the value of column. So that is ND2 and ND1. So let's now come and get the value of call option. We say that, what was the formula? Value of call, we say that the value of call is equal to S ND1 minus E ND2. Now you have your ND1, this one. You have your ND1. So you come and say S was 28. So this one is equal to 28 times ND1, which is now 0.3446 plus, no, minus, we have E, which is 40 times, this one we already calculated. What did we get? 0.9704. 0 times ND2, which is this one, 0.1841. So that is what you get, and that is the value of call option. Which figure are you getting? So it is 28 times 0.3446, that is 9.6488 minus 40 times 0.9704 times 0.1841. So that's 7.1460. So that is 9.6488 minus 7.9460. 2.5028. Mpaka hapo ndio sasa umemaliza the value of call option. Is it challenging? Kupika hapo, I know the only place that you might have a problem is at the place of normalizing. Normalizing what you had here, you normalize it by checking on the table, and then you add or subtract 0.5 minus or plus, depending on whether these ones were negative or positive. So the determinant here are the signs. They're the ones that will guide you whether it's negative or positive. When checking on the table, just check the positive ones, and then you'll now be able to calculate them. So that is 0.2, 0.5. Let's now look at one example from the first paper that you're having there. Tuone kama umeshika rada. Bado tuko na some few minutes. Tufanye moja tena. At any city. You know, if you have one in 2015 or last sitting, tufanye hiyo last sitting, sio? Kama iko hivyo. Normal distribution table. So the last sitting, nasikia ilikuwa this one. Cumulative distribution functions, they told you the exponential constant, Euler's constant. Okay. Na kwani hawakuweka, these guys didn't attach nini? I think mwenye aliweka hii hakuweka the table. The table must be there. The table should always be there. If they don't give you, namaanisha sasa unabeba yako. But we can be able to try it. Euler's constant. Can somebody try this? The current price is given as this. The continuous compound rate, our risk-free rate is that one. The variance of the rate is this is risk. So we are given current price in the S. Is it the S? Yes, the P or S. And then we are given here risk. We are given here risk, sorry, and then this R. Using the Black-Scholes option pricing model, estimate the value of European option, call option on the shares of the company that has an exercise price of 6.6. That's the exercise price 3 months to run before it expires. The Black-Scholes formula is given as follows. This is the formula. Can we try? In the Black-Scholes options. So the value of the European option, call option. So they want you to get call option. The value of call option. How many can try this? Can we try it? First, you put what you've been given down. That is 8 marks. That's why marks haikuangi kidogo. We can try it. Nana marks ni mingi. So you start by writing down what you've been given. Acha tufanye hiyo pamoja. Ndio mshike hii. So we have there, we have exercise price, that is E. E is given as 6.6. P is given as, or they call it P, yes, P. P is given as, that is 7. Then we have R given as 8%, 0.08. And then we have variance. They have not given you standard deviation, they have given you variance. The variance of the rate of return on the shares will 12. So that is variance. 12, right? Percent. So 12% is the same as 0.12. What else are we given? Time is 3 months. T is 3 months, which is the same as 0 point. 3 months is the same as 3 over 12. 3 over 12. So month must be in years. So 3 over 12 is 0 0.25. So from here we can do it, right? Thank you. The only thing that you can do for me is to respond so that I know that we are together. So let's start by getting the formula for value of call. We are told value of call is P into N D1 minus E into small e raised to RT N D2. That's the formula here. So we need to get D1, not ND1 first. We need to know D1. So we are saying that D1 is equal to Ln, that is natural logarithm of N, into P all over E plus into R plus standard deviation square all over 2 T. Then on this, we have this T, right? And then we have D2. D2 is equal to U1 minus standard this one. Right? So from here, we can be able now to start solving our problem using the information that we have. This one is December last year, 2023. So we come here and now look for the figures. So let's start by solving our D1. So D1 here is Ln of this figure. What is it? We have there P, which is 7 all over 6.6, right? Plus R we know, 0.08 plus 0.08 plus variance is given already. So we have 0.12 all over 2. Time is 0.25. All these, we are being told that it should be under this one square. So that is 0.12, the square root of that. This one is the square root of this is this. So that is square root of that times T times square root of T, which is 0.25. Using your calculator, just say square root of this times square root of this. What do you get? What do you get? What do you get? Twende tu pole pole. I know the first time most people didn't understand. So 7 all over 6 point, this is 6.6. What do you get? Then we get Ln of that. So 7 divided by 6.6. You'll be getting me the natural log of 1.0606 plus this one is a half. That is 0.06 plus this one, we have 0.14 times 0.25. All these over. What is the figure here? Topista, calculate for me as square root of 0.12 times square root of 0.25. Calculate for me that. Ruth, kindly calculate for me this. You are getting 0.1 7321 or 32 1732. So that is okay. Get for me Ln of this one, the way you did the other one. Ln of this, what is it? Ruth, is that Ln of this only? Thank you. So then we are going to have 0.0588 plus hiyo mkimultiply unapata ngapi? That's what I can do. So 0.14 times 0.25 higher. What am I seeing? 0.14 times 0.25. 0.35. So that is plus 0.35. 0.35 all over 0.1732. What is the answer? What is the one? 0.5416. Good. Now that's the one. We have not normalized it, so we don't call it ND1. If you normalize it, you'll call it ND1. Now, in the example that we did, tulikuwa tumepika hapa, then something told me that, can you just go ahead and normalize it? Nikakumbuka, wacha tumalizane na zote, and then we shall normalize together. Now, in this one, you can now get D2. So D2 is equal to 0.54. It's equal to D1 minus, right? So D2 is equal to 0.5416 minus, that is this one, 0.1732. So what do you get? Zero point 3684. Now, these are now the figures that we have. Tuko pamoja? These are now the figures that we have. So can we normalize? So you can now normalize the figures. Normalize. So the one, we shall have 0.5 plus. Why? We don't minus because the figures are positive. So we have plus. But you don't take it the way it is. Hii one, go to the table. The answer that you will get, kuja hapa. So the tables that we are having, mwenye alikopi hakuweka, hakuattach your table. But let's go and see any table that is available. You will be using the table that you'll be given in exam room. So let's come to the table. Wapi table iko wapi? Hii bado haina table. I'll assume that this is not, but this one, though wamesema it is one-tailed. One-tailed inamaanisha side moja tu ndio wana focus on. But we shall use it for illustration. In exam, utapewa table. So you'll go to the normal table that they have given you. Then you come here. So here, tuko na 0.54. So you come to 0.5 here. Then unafuata 4 iko wapi? 4 mpaka hapa. Are we together? It is 0.5. Then you look for 4. Hakuna kitu ingine after 4. Unaona hapa hakuna kitu ingine hapa. So you only come to 4 here. So your answer is 0.2054. 2054. 2054. So you add to 0.2054. And then you say now you are, this is now called ND. Kwa hivyo umenormalize. So it is ND1. You now have it as 0.7054. That is now your ND1. Now ND2 is also you come to 0.5 plus what you're going to get there. Hapo kwa table, sinarudi hapo. So for table, we are now looking at, this was D2. The figure of D2 is 0.3. So look at the columns. Tafuta where there is 0.3. Ukifika hapo, go across. Tafuta mahali kuna 0.06. Hii ndio sasa unatafuta. Right? So this one I think we can round it off. The other one was 5. Yes, this one we can round it off. So this 6 equate to 7 to be accurate. Because we need to use it for 2 decimal places. So this one can be 0.37 because we round it off. So we look for where there is 7. And in exam, even if you are to use 6, but utapata to answer. I'm just trying to say that you only take 2 decimal places. Hapa tumechukua 0.54. Hapa 0.37 kwa sababu ya hii. So come to the table. You come to the table. Look for where we have 0.3 and then ufuate 7. So 3 ndio hii. Move up to where there is 7. Across mpaka hapa. Right? Take 0.1443. 0.1443. So you add to this one 0.1443. So you'll be having your 0.6443. So these are the figures that you're going to use as ND1. Now come and punch them here. Tumemalizana na hii na hii. We have, this was D1, not ND1. This is D2, not ND2. It only becomes ND1 after normalizing. So you come here and now have your figures. So we have P, which was 7. So you can say that 7 times ND1 was 0.7054 plus the other one is 6.6 times Euler's constant. We can now look for it. Euler's constant of E negative, what was time? 0.08, that is the rate times time is 0.25. What do you get? This one is equal to Euler's constant of 0.08 times 0.25. So it is negative 0.02. Can you get me that figure? Ruth, get me this figure. Wake up. E shift E that one, negative. What do you get? So you are having there 0.9802 times now ND2. We have calculated it here. We say that if the figures that we're getting D2 and D1 were positive, you add direct. If they were negative, you take 0.5 minus that answer. So that is 0.6443. The answer that you're going to get there, that is the value of call option. That is a BC. So BC is equal to. So get me that figure. What is the value of call option? Your timing may end up, but we shall do only one example. So we call it N. Calculate for me that one. Maybe a figure. Because of this. So once you've gotten that, you can now get value of put option. From the formula I gave you, what is the value of put option? Value of put option which we call VP is equal to VP is equal to VC minus P plus E all over ERT. So it's basically the same as this ERT. And of course now you know these ones here. There are these ones here. They're easy. So your answer was 9.08. So value of put option is this is C. That is 9.08 minus 7. P was 7 minus 7 plus this one. You have the product of 6.6 times 0.9802. What is that? That is the value of put option. So examiner can ask you value of call option, and then after that, they also tell you to solve put option. Solve the put option. So I want us to look at a question in May 2016. Are we supposed to add or less? Hapa you less this minus this plus hapa kuna minus, but then this one is plus. So we see this
I
one.
mean the call option.
Huh? Come again. Value of call option si tumepika hapa. Is that problem here? Ama unasema what is one?
Yes.
That is minus. That is minus. This minus this. Mali kuna add ile D1. D1 ndio tulikuwa tuna have. D1 was ln into P all over E plus E R T N. No, how was it? I'm going to give you a wrong thing. What was the formula for N1? It was plus R plus square over 2. That was the T1. Hapa ndio kuna plus, hapa naye kuna minus. You're getting a different figure. Value of call is 9 point. Somebody's getting 1.9.106. It doesn't matter. Sasa unajua sasa hiyo ni accuracy yako. How accurate you are. But again, somebody's talking.
Hiyo working ya pili ndio wanasema umeandika plus rather than minus. Uangalie below the formula hapo.
Below hapa.
Yeah.
Oh, okay. So it should be minus. Should be minus your plus. Thank you. So minus, that means that easy product, easy multiplication, so you'll have to deal with this one separately. Then you minus. So you get the correct answer. I go minus, get the correct answer, substitute here. Thank you. Now, that is about that one. I want us now to look at one question. Time 9 minutes. You can try it if you want to try it later. Otherwise, you can try it together. In which paper? I wish it comes in exam. In April 2022. April 2022. Hata kuna ingine ilikuja hapa. The current market price Kanga is that one. A call option exercise on the company's share with an exercise of this one with 6 months maturity. The option can be only exercised on maturity. Wakisema only on maturity, that is European options here. Risk period is given there, and then they have also given you the variance. Then they are telling you to calculate the black shots. So this one, how many marks? 6 marks. Those are 3 marks here. Okay, let's look at 2016. If it is different in any way. Number 2 mu extend to leo peke yake. Tumalize hii call options. Sitaki kurudia black shots again. That's why I'm trying to see that if you can try another one for the last time so that I can test your understanding. I don't want to make another class for black shots. Money market, hizi sasa mtapotea nayo, si ndio? Kazenga Limited, whatever. The rest are here. Forward market, money market, then you advise comparing the two. Iko sawa. EPS, Modigliani iko sawa, si ndio? NPVs iko sawa. So that is 2018. Let's see in May 2016 inakaaje. It's 20 May. Pia tulikuwa na, I don't think, black shots. Highlight 2 shortcomings of the black shots option pricing model. What do you think will be the problem with this black shots? If you are told to ask to calculate to highlight 2 challenges. Hii ni rahisi. Angalia formula. This one assumes that risk, when you are pricing, you're using some constant figures. So it assumes that risk is known, which might not be true. It assumes that the risk-free rate of return you can determine. It also assumes that, so it assumes that there is this one, you can determine or determine risk. You can also determine the free rate of return. So these are the first 2 weaknesses. So you are told, you say that is not practical in real life. You cannot say that you can predict the risk-free rate of an asset, or you cannot say that the risk of an asset can be well determined. That can be a weakness. So from the formula, you can be able to get that. So in exam, just open your mind a little bit. Usiache question iende. This one now. Question 1, May 2016. So the question says that Planet is considering undertaking a 20-year project which requires an initial investment of 250. An initial investment of 250. million in a real estate partnership and whose present value is expected cash flows of this one. So hii ni nini umepewa hapa? What are these two that you're given? Just speak. This is a project, this is the present value of the project. So hii ni nini na hii ni nini? Planet Limited has the option to abandon the project anytime in the next 5 years for 150. The option to abandon, which option is that? Option to abandon. Which option is that? Guys, tuongee. Nataka hata muongee ndio tuende haraka. Just unmute yourself and speak. That is, You're being told that the period is 20 years, which requires an initial investment of 250. That is IO in a real estate partnership and whose present value PV. Present value tulisema ni nini? Present value ni? Check your notes bana. Tukianza, tulisema hiyo nini? We were defining them. Na nikaandika PERQ. What was present value? Notes ya jana. Usiniangushe tu hivyo hivyo. Utafanya mwalimu wa maths aseme only those who will give answers can go for lunch. Present value. Naona vile hii maths ni mingi 10. Ruth, do you have it? Yesterday, did you write something like that? Or when we were starting, I think it was yesterday, when I introduced the options. Was it yesterday? Yesterday ilikuwa Thursday. Sun? Yes. Topista. In your books, P inamaanisha nini? What did you write? P.
It's the present value.
Huh? Present value, that is what I said. Spot price, present value, or current price. So you've been told that the current price, which is the present price, present value, is 250. P Limited, Planet Limited has the option to abandon the project anytime in the next 5 years for 150. So which one is this? Wakati at abandon at 150, which price is this? Huh? Type. Ama unaweza ongea. Wakati at abandon, hakuna option ya ku abandon. Option to exercise. Option to exercise. Sasa umepewa exercise price ndio hii. Ata exercise in 5 years time, akona right ya ku exercise at 150. So umepewa E, umepewa P. Variance of the present value of the cash flow is this one, and the 5 years risk-free rate is given as this. Imagine umepewa kila kitu the same time. FM ukitaka FM ikuwa ngumu, itakuwa ngumu. Ukitaka ikuwe rahisi, inakuwa rahisi. Huyo examiner amekupea kila kitu. Uoga tu mko nayo, uoga kadogo tu. Unaona hizo figures unasema sasa hao watu wameleta story ya present value here. But remember what I told you, that options are about capital appraisal. So we have there the IO, you're given as 250. And then you are given the P, which is 254. They have given you the E, exercise price, which is 150. And as I want anytime abandon at a certain price, that is the price that you can exercise. All right? You'll be given R to be 0.0. R is 0.007. And then what else? T, you are given us 5 years here. And as an exercise at the end of 5 years. So that is T, 5 years. Then what else are we given from that question that have not included risk? Variance, you are given us 0.09. So that means that our risk alone is 0.3. Sindio? Square root of this ni nini? Sini? Ruth, unashangaa. Now from here it can flow. Sindio? What was the question now? We shall break down these things like that. The Black-Scholes formula is given as that, which is direct. The put-call parity, umepewa hadi formula. Huyu jamaa alikuwa mzuri sana. Alafu nakwambia, the net present value of the project, including the option to abandon the project. The NPV of the project. Including the option to abandon the project. So we start by getting, how do you normally get NPV? NPV is equal to IO, or it is normally present value minus IO. Clear? And present value is the value of call. Present value is the value of call. That is the PV minus IO. IO shapewa. Wacha tuwe pumzika kwanza. Calculate for me the value of call. Can you calculate the value of call? And being that this person wanted to abandon is which kind of option? Which kind of option is it? Abandonment. Check what I gave you. Let's lay down this. Yesterday we said that to abandon which kind of option? Not real. Iliweka in bracket vizuri. Put option. So it means that if this person wants to put to abandon, then we are now calculating the value of put. Kama ingekuwa you want to expand, then you can calculate the value of call. So in this case, we don't calculate now the value of call kwa sababu yeye ni the seller, yeye ni an abandon. So that is put. If angesema that you wanted to expand, then it means that we are now calculating the value of call, that is VC. So therefore, these guys are telling us that now we calculate the value of put, which is now VP minus IO. So what is guiding us is the action he wanted to abandon, and abandon is put option. So at the time he's abandoning in 5 years' time, what will be the value of abandonment? That is the value of put option at that point. So of course we need to calculate this, and I know you can. We just need to do it very fast so that we save time, if you allow me. So we start with the one that you are used to. That is the value. You cannot calculate the value of put without the value of call. So you start with the value of call, and we say that the value of call is, remember that formula. It was P ND1 minus E ND2. Is it done like that? Tuelewane. Iko kitu kama hiyo. Na kama ni hiyo, we now get N, we get D1. D1 we say that is Ln into P all over E plus R plus standard deviation all over 2T. All these we have over T. So we can do that. Our P here, chukua Ln into 254 lower E, which is 150, plus R, 0.07, plus, this one squared, we are given 0.09 over 2 times 5 years. There are times already in years. time is already in years. Are we together there? Haya. So, mimi naomba tufanye haraka haraka because of time. So this one is ln into 254. 254 divided by 150. So it is ln of 69 plus get me ln. This one. Naona watu wameanza kuchoka. Of course, this one should be all over. We have this one property. So after this one will be 0.3 times the square root of t is 5. So the square root of 5. Five years. Hebu mnipe figures tuende. Hii ni 2.29. This one. Fine. So 2.24 plus. Hii ingine nishapata ni along square root of this. 3 times square root of 5. Nipe figure. Can you confirm it? Natural logarithm of this one is okay.
2.25 is the square root of 5.
Square root of 5. Nipe hiyo na decimal places mingi. Haiwezi kuwa 2.24. Nipe hiyo 4 decimal places. Is 2.24?
2.2361.
I'm repeating. When you are still going on with calculation, haujafika mwisho. Try to have them in 4 decimal places. Wakati una wind up, that is when you round it up. Don't round up ukiwa huko. You'll be far from the answer. Hii, you round off at the last stage. Hapa kwa calculation hizi, give it 4 decimal places. So nipe ipiga basi. ln root wewe umechoka.
0.52667.
So 0.52667. So 67. Can give this one 4. Haya. You can now tell me P1. And then D2 is equal to D1 minus. So this one is the same as D1, which you are going to give me the answer, minus 0.3 times 2.2361. Get me the answer. So D1 is 1.6. Thank you. So 1.6264. So what are you getting there? What is D2? Huh? I hope you guys are confirming if D1 is okay. Edwin, Jen, I hope you guys are confirming whether D1 is okay. So normalize then. Once umezipata hivyo, now normalize. So you say that D1, come to the table, tafuta hii. Kabisa. Go to the table, tafuta 1.6, then tafuta column ya 4. What we are doing? Topista hizi kwa 16 jameni. 16 hata hiyo table haina. 16. Hii. 16 hakuja aje. Hebu mfanye haraka haraka, nani ana confirm? Hii hata hiyo table iko. Hii hata utafuta kwa table hiyo 16 sasa kama utapata. You see the range there. Ukiwa wrong utajua tu hapa naye imetupa mbao, imetupa slingi. Hapa nimetupa slingi. Unaangalia table, unaona table can only accommodate up to some extent. Ona imefika hapa na unapata 16. Wewe huwezi pata hiyo. Come to 1.6 na uangalia hapa 1.6 under 4, under 4 ndio hii. 1.6 under 4. Unajua ukiwa wrong unaona tu. So it is 0.4495. 0.4495. So this one we have 0.5 plus 0.4495. This one is going to be 0.944, 0.995. Get me the 2. Anyway, this is going to hesabu. Anyway, iko sawa. So it is 1.6. That makes sense. Haya, tukuje hapa. Tunakuta hii. Mimi hizo stories za errors kidogo sana. So 0.97. So come here. Tafuta 0.9 ndio hii. Then go where 7 is. Kimbia 7 iko wapi? Ndio hii 3340. Haya, so nakuja hapa. Tunasema 0.5 plus 0.3340. Your answer is 0.8340. Haya. Those are the ND1. Now you have normalized them. So they qualify to be called ND1 and ND2. Those answers. Huh? Now, what is the next step? Is now to get call option. Because we can't move to put without getting call. And we know this person is a put person. A put person, another who abandon. So we can't P, C. If we say that is P ND1 minus E ND2, right? So P was given as 254 times ND1, which is now this one 0.9495 minus Euler's constant. Get me this figure. E RT is the same as E into R and T. Right here, so 0.07 times 5. So that is, what is the figure? Kabla watu wachoke wote. 7 times 5. Give me Euler's constant of 35. E negative 0.35. Get me this one. Ruth, wenda najua utaniokoa hapo haraka. Hebu take. D2 tulipata ni ngapi? Were you supposed to round off? What was the figure for D2? D2. What was the figure? Oh, 97. 0.97. 0.97 inakuja na figure gani? Zero point nine seven, so 999, 0.97 or 334. So we are okay. So that's okay. So umepata hiyo ni, so umeipea hii figure. So it is E. This one is 1.416191. So we have E, which we have 150 times 1.4191 times, and the one we have calculated is 0.83340. Na topista ako karibu kuniambia adjust the board. Yeah. Nimeadjust sasa. Endelea. So what are you getting as the value of call? Value of call option. Topista sijasema upotee. Nataka tu value of call option, then we get the put because it was supposed to be abandoned. Then we get now that will be the value of put. We look at the issue of abandonment. If it is expand, kama wangesema expand, unafika hapa, hiyo ni value of call, sawa? Lakini wanataka put, so inabidi tuendelee. So the total is 60. No, Edwin is getting E to be 0.7047. Who is saying the truth, guys? What is the value of E? That difference is quite high. Can we work together, Jen? Can we work together? Should be 0.7 or 47. So here we have 0.7 or 47. Na mkinyamaza tutakuwa tunaendelea tu. 0.7047. Haya. Calculate now. Now calculate it again. So we have 254 times 0.9495. 241.17 minus so value of put is equal to DC minus P plus this one we know. This times this, so we can have 153 07, but yeah, 785 plus 254. So minus 254 times mbona mnapata hivyo? Mbona mnapata hivyo? 153. Hii ni positive. So this one times this one, hii imepata around 105. 105 ukiongeza na hii 153 inakuja 258. 258 minus now 254. Hatuwezi pata 13. Hatuwezi pata 13. This is the only one that is negative. So calculate these ones. Answer that you got, add na e minus this. Or maybe this minus this, you'll get an answer. Sema kweli. Thank you. Hapo sasa tick. So this now the put, it is the value at the time of abandonment. It's the value of put at the time of abandonment. So if you are told now to calculate now the NPV. NPV sasa unajua. NPV is equal to now the VP minus IO, which will be 4.7835 minus IO is 250. So what is the answer that we're getting? Negative? Unapata negative what? Yetu yamaliza, unapata negative what? Sorry. Umepata 4. So NPV is equal to P, that is the NPV of the project, that is the P minus IO plus VP plus VP. P minus IO plus VP. So that is the initial value of the project. So you will have 240 plus minus 45 minus 1 minus 250 plus VP, which is now 4.7835. So it is going to be 8 point. Is it 8? 254. Sorry, this is 254. 254. So that is 8.7835. 8.7. That is the last part. That is the last part of that question. That is the value of the project, including the option, including the option. Value of the project, including the option. So this is the value of the project, including the option. Including option. NPV of project. Including option. Without option, you simply leave this one out. Without option, you only have this only. NPV without option is this one, like this, without, this is the option. So what was the examiner saying? That was 2016. It is 2016 what? 2016 May. May. November. It question number 5, or which question number was it? Question number 1. This one. They are saying that the net present value of the project, including the option to abandon. So that is including the option, including the option. So you have included the option to abandon. Without the option to abandon, will just be this minus this, but including it is the initial price, which was this, minus IO, plus now the option to abandon. So we shall stop there. Shall stop there. NPV minus IO plus BP. I don't know if you guys umeelewa the concept. Just to explain that one, yeah, abandon. You see now, no more NPV. NPV is normally the present value minus IO. But when you have scrap value, you normally have, you add scrap value there. That's the value of the last residue. So you have the scrap value, which is SB. Now, if there is an option to abandon, meaning that akona NPV, akona present value, akona IO, but again, at the time of abandoning, kuna ile figure atapata. There will be value at the end, like a scrap value. So this is the scrap value of the option, ile pesa atapata. So that is what we just added. So it's the same present value minus IO plus the value of abandonment, which is the same as the value of the scrap at the time you are abandoning it. Tunaelewana? Ruth, tumeelewana hapo? Ordinarily, when you have a project, you'll get the NPV minus IO. Alafu najiuliza, is there any scrap value? You always add scrap value. Now, this is also the same as option. Akona present value of the option, akona IO. At the time of abandonment, after 5 years, una scrap value, itakuwa na value yake tena. You add it the way you are adding scrap value. So that is why we added the value of abandonment at that time. So unaona examiner is very clear, including the abandonment. Including the abandonment. Na hapa tuliambiwa whose present value. So PV was already there. IO was already there. What we didn't know, which you have calculated, is the value at the time of abandonment. That is the put price or put option. The value of put option at the time of abandonment. That is now like the scrap value. Na hiyo ndio tumeongeza hapo na tukamaliza hiyo story. Is it even 4 or 8? Yeah, it is 4. So that is a 4. So ukiongeza hiyo 4 nakuja hiyo. So thank you so much, vumilia. But at least you've learned something, a different way of answering this question. I wish they can bring something like this one. Ikuwe ngumu kidogo na ikupea 12 marks so that you only look for 38 na upite mtihani. Najua hiyo ni ngumu kidogo, lakini unaona sasa ina flow, alafu inafanyia watu hivi, wale waoga na wenye waingii class wanatoroka, wanarudi next semester, na wale wametia bidii kama nyinyi wapite in Jesus name. Wapite in Jesus name. So kesho tufanye lem. Kesho tufanye lem. I think FM now you should be ready for exams. Maybe I can only have 2 classes here revision. There are areas that I might want to look at, but you're okay. Kesho ni lem. Tumalizie. Once lem 6, what do you think? 6 is okay?